Hi. So today I want to look at more SAT questions, particularly ones that require you to know your exponent rules. So here we have a question: if x to the fourth equals y to the 12th, what is x in terms of y? But first things first, I just want to remind you that when we talk about exponents, whenever we have an exponent, we say we have a variable z and we have exponent 2. And we raise this to another power. So we raise z to the second by 3. All this means the base stays the same. So z stays the same. And we have 2 times 3 equals 6. So that's our new exponent. And we know this is true because if you write out this inside, if we write out z squared, so z times z, and we have to do that 3 times, we can see that we have z times z times z times z times z times z 6 times. So anytime we have a power, a variable raised to a power, raised to another power, we just have to multiply the two exponents together, and that would be our new exponent. So knowing that, okay, so let's rewrite our x as y to some variable, to z, right? Because z could be 1, z could be 2, so we're just going to rewrite x as y equals z. So remember that we're raising x to the 4th power, right? So this is being raised to the 4th power, so that means we have to raise y to the z to the 4th power. So we can rewrite the equation as y 12. And remember what we said, when we raise an exponent to another power, we just have to multiply those two together. So we get y 4z equals y 12. And we notice that the bases are the same. So how do we get 4z to equal 12? Well, we can rewrite this as a simple algebraic expression, or equation, I'm sorry. 4z equals 12. And from here we can divide by 4 on both sides, and we would get z equals 3. So now that we know what z is, right, z is the exponent to y, we can say that x in terms of y is y to the 3rd. And again, we can prove that because we can plug this back into the original equation, x fourth equals y to the 12th. So remember that this y to the 3rd is equal to x. So y to the 3rd, and with the raises to the 4th power, equals y 12th. Multiply the two exponents together. 3 times 4 is 12. So we would get y 12 equals y 12. So we know that y equals 3 is our right answer. Okay, so here we have 2 to the 4x equals 16. And there's actually two ways that you can probably solve this. And I want to show you both ways. So the first way is rewriting 2 to the 4x. So let's rewrite this equation. So remember, if you have two numbers, or if you have two terms multiplying each other in the exponents, that means that you can split them up like this. Right? 2 to the 4 to the x is the same thing as 2 to the 4x. So we can solve what's in the inside the parentheses. So 2 to the 4, it would be equal to 16 to the x. So now that we have this, we can plug this back into the original equation. So 16x equals 16. And in order to solve this, we can remember that in order for the base to remain the same, the exponent has to be equal to 1. So x equals 1, because when you plug in y into x, you're just going to get 16. So 16 will equal 16. So this is going to be our right answer. The second way we can solve this, let me just move all of this over here. So the second way we can solve this is if we write the 16. So let's 2 to the 4x. Let me rewrite that. 2 to the 4x equals 16. Well, if we look at 16, we can If we look at 16, we can simplify it as 2 to the 4. We can recognize that 16 is 2 to the 4th power. And so already we can see that our two sides of the equation are very similar. So now all we have to do is figure out, we'll take a look at the exponents since our bases are the same, only focus on the exponents. So how do we get 4x to equal 4? In other words, 4x equals 4. And when you divide both sides by 4, you arrive at the same answer. X equals 1. Let's take a look at one more. So this one is, if 3x minus y equals 14, what is the value of 8x over 2y? Okay, so this one follows the same rules as the previous two, except the only difference now is that they have an equation here. But don't be frightened by that. So let's first focus on this. Let's first focus on the fraction that we have, 8x over 2y. So anytime you're presented with a question like this on the SAT, chances are one of the numbers is going to be can be rewritten as the other number, but just in an exponent form. And what do I mean by that? Well, let's look at 8 and 2. 8 can be rewritten as 2 to the 3rd power. And remember that we have that x, right? So 8 equals 2 to the 3rd power. So we'll rewrite that 8 as 2 to the 3. And we'll have that x there. And we have that over 2y. And remember, anytime you have a power, so 2 to the 3rd raised to another power, you just multiply the exponents. So we'll rewrite the top simply as 2 to the 3x. So now, going back to what we know about exponents and exponent rules, anytime you are dividing our exponents, right, and the bases are the same, so here we have a base of 2 and base of 2, so we can ignore the bases. All you want to do is subtract the exponents from each other. That's all you want to do. And what do we get when you subtract the exponents with each other? 3x minus y. Well, we can see here that it actually matches the equations that they give us. And it tells us the answer, 3x minus y equals 14. Since we know what our exponent is, and we know what our base is, we can rewrite this equation to equal 2 to the 14th power. So what are the key takeaways here? So, anytime you have an exponent raised to another exponent, the rule says that all you have to do is keep the base the same and multiply the two exponents together. So 3 times 4 is 12. And we already proved this, so I'll prove it to you one more time, right? So x to the 3rd is x times x, right? And we just have to do that 4 times. So x times x times x, x times x times x, and then x times x times x. So this is x to the 3rd 4 times. And if you count the number of x's, there's going to be 12 of them. So that's how we get x12. And this works for any exponent. So even if you had, let's say, g to the 25th power raised to the 5th, this would equal g to the 125th. It may be a big number, but this rule will always be true. The second thing to always remember is that when you are dividing and multiplying exponents, so when you have something like, let's say, z to the 5th over z to the 2nd, right? This is going to be z to the 3rd. And we know this is true because if we write it out, so z times z times z times z times z over z squared, so that's z times z, we can see z over z cancels out and z over z cancels out. So that leaves a 1 in the denominator. And we have 3 z's on top. So that would equal z to the 3rd. And same thing as if you were multiplying them. If these two numbers were being multiplied. Z to the 2nd, so that's z times z times z times z times z times z squared. All we have to do is count up the z's, or just add up the exponents, and we would get z to the 7th. And It's also helpful to remember that the SATs probably will not include exponents this simple. In fact, it will probably be like x to the or z to the 5x times z squared. So you would end up something like z. So this would be, so you would end up with something like z to the 5x times z squared is equal to z to the 5x plus 2. And you'd probably have to find out what the x is, or what this equals if they give you the x. Same thing if you had an x. Same thing if you were to divide these two exponents. So z to the 5x over z squared. This would equal z to the 5x and minus. Remember, you have to minus these two because you're dividing. 5x minus 2. And if they were to tell you that 5x minus 2 is equal to 8, we know that we can plug this 8 right into this exponent, because we know that this 5x minus 2 is equal to 8. So that we can rewrite this answer as z to the 8. So z to the 5x divided by z squared is going to be equal to z to the 8. It just depends on what the question gives you, but these rules with dividing and multiplying exponents will always be the same.